And Kevin Mack is an Oscar-winning digital artist at Sony. Nehalem will enable artists using new usage models that literally are computationally out of bounds for today's hardware and software. And this particular animation that we're showing, is complexity of abstract 3D animation, right? It's showing a black box containing forces that are about an explosion of evolving capabilities inside of this visual world. And now seeing the output, right, you can only sort of envision the computational complexity. What I now like to do is show that rendering being conducted in real time. We're going to compare a Harpertown system to a Nehalem system. And on my right, we have the Nehalem system. And on my left, we have the Harpertown system. And now we're actually going to go render that image in real time, right, as we're going on here. And as that starts to develop on the two screens over here, as we benchmark this, we see that on this type of application, computationally very demanding, bandwidth very demanding, we're seeing the Nehalem systems result approximately 2x faster. And this is the expandable segment of the Nehalem family. So this is our high-end expandable server, an 8-core wonder, right? So the first showing of the 8-core Nehalem EX silicon. We'll be excited to talk to you more at IDF about this as we go through next year. Nehalem is the unquestioned performance leader. A performance user's dream is the Nehalem platform. It's sort of like Michael Phelps. The only records left to beat are his own, right? And Nehalem, right, is upping the ante on Intel performance records in the industry. And I want to show you just a couple of examples of our high-end desktop applications and what we're able to do, right, with the Nehalem system. Here on stage, I show a demonstration of the next release of Lost Planet Colonies, a popular game. And with it, we have two equally configured systems. Both of these are 3.2 gigahertz compared to 3.2 gigahertz. This is a quad-core Yorksfield compared to a quad-core 8-thread Nehalem, same memory, same hard drive, etc. And as you can see by the frames per second calculation that are going on here, generally the Nehalem is greater than 50% better over this application environment. It's showing the value and strength of the Nehalem microarchitecture. So, the whole power system in the Nehalem is very powerful, capable. Can you just sort of summarize it to the audience?
Yeah, I think this is a multi-generational thing. We are not building something for one generation. I think this is going to be a breakthrough infrastructure which will survive for quite a few years to come, which is innovative sensors, innovative drivetrains, and brains behind the whole operation.
High-performance computing demands incredible performance capabilities, but it needs so with high density and energy efficiency. It typically consumes incredible amounts of bandwidth, right? It requires low latency interfaces to that memory, and the Nehalem delivers a 3-channel DDR3, which provides a tripling or more of memory bandwidth into the socket. It also gives large footprint, up to 288 gigabytes of memory capacity in a 2P server, a stunning amount of workload possible, the world's most adaptable server platform. Looking at that specifically in high-performance computing, we go to customers like NASA. And NASA's thirst for computing is literally insatiable. And I'm pleased to announce that NASA has just completed the first phase of a multi-year project called Pleiades. NASA is anticipating the delivery of thousands of Nehalems for the second phase. And NASA will be using this for petaflops of performance for key problem areas like space exploration as well as climate modeling, which is the simulation that you're seeing running on the screen right now.